Good morning to one and all. My name is V. Abhijit Kumar. My roll number is 24951A6602. I'm studying in CSE AI and ML, that is Computer Science and Engineering with the specification of Artificial Intelligence and Machine Learning, 4th semester, Institute of Aeronautical Engineering. In this Tech Talk video of the subject of Web Systems Engineering, the topic I'm going to talk about is the radio that can hear over itself. Self-interference cancellation that allows radios to transmit and receive on the same frequency. Now let's go through the contents. In the first place, I'm going to explain about full duplex foundation. Uh, there will be understanding simultaneous wireless communication. Next, we'll go to discuss about half duplex limitations of half duplex systems. Then we'll discuss about understanding self interference, the the core technical problem over there. Next, we'll discuss about self-interference cancellation, self-interference cancellation techniques, hardware and software solutions. Then we'll discuss about impact of full duplex communication architecture, real-world implementation benefits, and after that, we'll go to conclude the topic. An overall summary. Now let's go through full duplex revolution. Web systems today depend heavily on wireless communication infrastructure for their operation. Traditional radios have operated in the half-duplex mode for decades, fundamentally limiting available bandwidth and system performance. Self-interference has historically prevented simultaneous transmission and reception on the same frequency. But however, recent technological advances now enable radios to cancel their own interference effectively. This breakthrough forms the foundation of full duplex communication, dramatically enhancing the capabilities of modern web systems and network architectures. Now let's discuss about half duplex limitations. Here we have four limitations. Spectrum inefficiency. Half-duplex operation wastes valuable frequency resources by requiring alternating transmission windows. Increased latency. Separate time or frequency allocation introduces communication delays that impact real-world services, real-time services. Throughput constraints. Limited data throughput directly affects performance of real-time web applications and services. Dense environment issues. High congestion in wireless environments restricts scalability of web applications and IoT deployments. Hence, these are half-duplex limitations. Now let's understand about self-interference. The core challenge over here is that when a radio transmits, the powerful outgoing signal inevitably leaks into its own receiver circuitry. This self-interference completely masks the much weaker incoming signals the receiver is trying to detect. The power imbalance between transmitted and received signals can exceed 100 dB, making a detection of incoming data nearly impossible without effective cancellation. Here we have a key insight. Self-interference is deterministic and predictable, which enables computational cancellation techniques to work effectively. Hence, this is all about understanding the concept of self-interference. Now let's discuss about self-interference cancellation techniques. First of all, analog, the the interference is provided an analog, then it becomes digital and adaptive. Modern full duplex systems employ a multi-layered approach combining hardware and software solutions. This enables simultaneous transmission and reception on the same frequency with minimal performance degradation. Now let's have a technical deep dive. Cancellation methods. We have three cancellation methods. Analog cancellation. It reduces interference at the RF stage before signal digitalization using antenna isolation and circuit level cancellation. Antenna separation techniques, passive RF filtering, and active circuit cancellation. These all happen as a part of analog cancellation. Digital cancellation. It subtracts transmitted signals from received data using digital signal processing after ADC conversion. Known signal reconstruction, precise timing alignment, high resolution subtraction. These all happen as a part of digital cancellation. Adaptive filtering. It handles dynamic channel conditions and multipath effects through real-time algorithm adjustments. Machine learning algorithms, real-time channel estimation, and continuous parameter updates. These all happen as a part of adaptive filtering. Now, coming again, analog cancellation, digital cancellation, adaptive filtering. These are the three cancellation methods. This is the technical deep dive. Now let's go through the impact of full duplex communication architecture. Single frequency operation. Both transmission and reception occur simultaneously on the same frequency band, eliminating the need for frequency division. Doubled spectral efficiency. Theoretical doubling of throughput by using the same spectrum for bidirectional communication simultaneously. Minimal communication delay. It eliminates turnaround time between transmission and reception, significantly reducing end-to-end latency. High throughput exchange. This supports intensive data exchange ideal for web-centric real-time network services and applications. Hence, this is all about the impact of full duplex communication architecture. Now let's finally conclude the topic. This conclusion, it, it's a beginning of a new era in wireless systems. Hence, self-interference cancellation transforms traditional wireless radios into full duplex systems capable of simultaneous transmission and reception on the same frequency. This technological advancement significantly enhances bandwidth efficiently whilst reducing latency, providing a robust foundation for high-performance, scalable, and real-time web systems. For web systems engineers and technical product managers, full duplex communication represents a fundamental shift in how we architect in network infrastructure. The ability to double spectral efficiency whilst minimizing latency opens new possibilities for responsive, data-intensive applications. As this technology matures and becomes even more widely deployed in the nearby future, it will enable the next generation of web systems engineering supporting increasingly sophisticated real-time services and IoT ecosystems. Hence, this is the final conclusion of the topic. And now, finally, I would like to thank the respected professor for giving me this wonderful opportunity to speak upon this wonderful topic. Thank you heartfully.